The next topic is angular momentum. Angular momentum is a new concept. The first time you are hearing this concept. Angular momentum. Linear momentum we have already studied. Linear momentum we have already studied. What is that linear momentum? An object having mass m moving with a velocity v, the moving along a line, moving with a velocity v, then the linear momentum is equal to mass into velocity. But here I am talking about angular momentum regarding rotation. Here if the body is moving with a velocity v, that m into v is said to be linear momentum. Understood. We have already studied. Now I am going to explain about angular momentum. All of you please listen. This is a new concept. If you don't understand anything, you can ask me. Suppose we have an axis. What is this? Why we have an axis? Or we have a point for the time being. Let me explain. We have a point, only one point. We have a point O and there is a body here. There is an object having mass m here. O is the fixed point, origin. Let us call it as origin. The distance between O and m is r. M is mass, understood? M is the mass of the body. There is a body here. Understood? Okay. Suppose this body has got an initial velocity v, like this. I will repeat, don't worry, but you have to listen carefully. This is a new concept. If you don't listen properly, you cannot understand anything. Suppose this body m has got a velocity v. What is the linear momentum of the body? M mass into velocity. The linear momentum of the body is mass into velocity. You know that. Okay. Now I am talking about the rotation. Suppose consider this just like a rope. Okay. Consider this as a rope. All of you please listen. Consider this as a rope. Understood? The body has a velocity v in this direction, but there is a rope. Imagine there is a rope. Imagine. Because of the rope, will the body move in that direction? No, it will rotate. If it is a rope connected to O, the body m unable to move along v. Instead of that, the body will rotate like this. The body will be moving like this, rotation. Here I am talking about a point mass. I am talking about a point mass. We assume that r is the length of the rope. R is the length of the rope. By some or other it has got a velocity v, but some part of velocity does not have any use. Only a small part of velocity. Because of a small part of velocity, the body will move like this, tend to move like this in a circular motion. Because there is a rope connected, the body will definitely move along a circle. There is no doubt in that. Now this v, listen, we know that v has two components. Understood? V has two components. This is said to be horizontal component. Let me redraw the diagram again. After explaining the formula, you can ask me doubt. Okay? After explaining all the formula, you can ask me doubt. This is the velocity of the body. This velocity, has two components. One component of the velocity is the component in the direction of r. One component of v is in the direction of r. Suppose this angle is theta, then you know that the horizontal component, you studied already, v cos theta. V has one component in the direction of along the rope. This highlighted one is rope. It is v cos theta. It is the horizontal component. Once I have written the formula, you can ask me doubt. Okay? And v has the vertical component like this. You know that horizontal component v cos theta, vertical component v sin theta. Here v cos theta does not have any role. in rotating the body. V cos theta is just waste, waste, it is just waste, no use. V cos theta does not have any use. That V cosine theta is responsible for the rotation of the body. The body is connected to a point O using a rope. V sin theta only has the role in the rotational motion. The body M will start rotating with the help of V sin theta. With the help of V sin theta, the body will start rotating with the help of V sin theta, because V sin theta acting like this. The V sin, because of the V sin theta, the body tend to move like this, hence move like a circle. What is the role of V cos theta? V cos theta does not have any role in rotating the body. So let me introduce angular momentum. Angular momentum, the proper definition is not given in textbook. The angular momentum means how strongly the body is rotating. How strongly the body is rotating. Understood? So the strength of the rotating body is said to be angular momentum. Linear momentum means also represents strength. A body of mass m with the velocity v, how strongly the body is moving, it is mass into velocity. In the same way, the strength of the rotation of the body is said to be angular momentum. It is defined as, for derivation is not there, this is a new term we are introducing. We are introducing a new term, angular momentum. I will repeat, but you listen carefully. L is equal to the strength of the rotating body, meaning that suppose there is a wall here, there is a vertical wall here. The more strength of the rotation, the more impact if it hit a vertical wall. The more strength of the rotation, the more impact on collision with another body. So the strength of the rotation is an important concept. The more strength of the rotation, more impact it will make on collision with another body. So the more if the R is more, the more impact it will make. You can imagine if the rope is sufficient length, if the rope has sufficient length and you are rotating it on collision, it will make a big impact. If the length of the rope is very less, on rotating the body, the impact is much smaller. The more length of the rope, the more impact it will make. So R has a role in determining the strength of the rotation. R has a role in determining the strength of the rotation. The mass has a role in determining the strength of the rotation. The more mass, the more impact on collision. R has a role, M has a role, V sin theta also has a role. The more velocity, the more impact. V cos theta does not come to the picture. V cos theta does not help the body to rotate. Only V sin theta help the body to rotate. The more V sin theta, the more impact on collision. So involving all these three terms, we are defining angular momentum. It is defined as mvr sin theta. mvr sin theta. Memorize the formula. mvr sin theta. Why we are defining like this? Let me write in this order. The mass has a role in determining strength of the motion. R has a role in determining the strength of the motion. V sin theta has a role in determining the strength of the motion. So angular momentum represents the strength of the rotation. Change the order, mvr sin theta. Where theta is the angle between. Theta is the angle between. R vector, you can consider R as a vector. Theta is the angle between R vector and V vector. The R vector direction is this one, understood? R vector direction is like this. V vector has direction like this. So theta is the angle between the r vector and v vector. Theta is the angle between r vector and v vector. So mvr sin theta, please memorize. So strength of the motion, I will write here. L represents strength of the rotating body. How strongly the body is rotating. Strength of the rotating body. Here I started with the case 1. We are considering a point mass, not a system of particle. Point mass I considered. If you consider the point mass, the angular momentum or the strength of the rotation is defined as mvr sin theta. The system of particle I will discuss after this. Okay, all of you please write down. And if you don't understand, you can ask me, okay? You please write down whatever I have written on the screen. You simply copy that. Case 1, point mass, okay? Point mass. If you have written and no doubt, you can raise your hand. Yes.
Can you say the dimension for the angular momentum, sir?
Dimensions. I mean unit. Yes, unit. Unit. I will definitely write. Okay, there is another representation. Okay. Anyway, the unit of angular momentum. You will not be getting a good unit. You will not be getting a good unit. Mass has the unit kilogram. V has the unit meter per second. R sin theta, R has the unit meter. Sin theta does not have any unit. Sin theta is opposite side by a hypotenuse. Meter by meter. Sin theta does not have any unit. So unit of angular momentum, it is not a good unit. Kilogram meter square per second. Okay. There is no any name for this. Kilogram meter square per second is the unit of angular momentum.
Sir, whether we have definition for angular momentum?
No definition is given. We can simply simply say like this. Angular momentum represents the strength of the rotating body. Okay, we can simply say like that. Then you can, if in exam if they are asking angular momentum, you can draw this diagram. Or there will be two cases, case 1 and case 2. You have to show, you have to draw the diagram and simply write the formula. Understood? For example, in exam, if they are asking for linear momentum, how will you define? No way. You simply write momentum is mass into velocity. You simply say like that. In the same way, angular momentum does not have any proper definition. Simply say it represents strength of the rotation. That's all. Clear?
Okay, sir.
Please raise your hand if you have written. So angular momentum is okay. Actually, okay. So then let me discuss case 2. Need not worry about derivation. They will not ask derivation for this angular momentum. Next is system of particles. I will write in the next page. I think it is better. Case 2. System of particles. But actually proper derivation is not given in textbook, but I will show in a simple way. I will show the derivation. so you will get a concept strong. Okay, so system of particles. So I discussed the angular momentum of a point mass. Okay, it is rotating, understood. Now let me discuss about the system of particle. System of particle will be a big body, every point having certain mass, understood. A big object, something like cylinder, sphere, just like that. Every point carries certain mass, understood, not a point mass. This is said to be system of particles. Let me redraw it again. We have a system of particle. Whatever may be the shape, it is going to be rotated about an axis. It is going to be rotated about an axis. Let it be the axis of rotation. Axis passing through the center of mass. Let us consider the simple case. For smooth rotation, it should be rotated about the axis passing through the center of mass. Should be rotated. So I want the strength of the rotation. Understood? I want the strength of the rotation. How strongly the body is rotating. Thus, the more strength of the rotation means it is very difficult to stop it. Understood? For example, an object is rotating. If you want to stop by holding it, if you want to stop, the more angular momentum means the more strength is required to stop it. The more force has to be applied to stop it. The less angular momentum means a little force is required to stop it. Understood? So the strength of the rotation. So all of you please listen. System of particle. So we have every object carries certain mass. Understood? In simple, the derivation does not take too much time. So let me explain that. Then only you will get a proper idea. Concept will be thorough. So that's why I am discussing. So every point will have a certain mass. Understood? Let this point has mass m1, which is at a distance of r1 meter away. R1 meter away from m1. Understood? Okay. Next, another body having mass m2, which is at a distance of r2 meter away from axis of rotation. Another mass m3, which is at a distance of r3 meter away from axis of rotation. m4, m5, etc. All of you please listen. If the body is rotating with an angular speed omega is very important. You studied in the chapter motion in a plane. Anybody, do you remember what do you mean by angular speed omega? Anybody? What do you mean by angular speed omega? Nobody is responding. Raj, Ashlyn, Ormindo, Said, you are not responding. What do you mean by angular speed? We studied in the chapter circular motion. Motion in a plane. Nobody is responding. Devasri, you don't remember? Angular speed, you don't know? Devasri? No. Nobody's? Angular speed means, I have already discussed that. Angular speed omega is the angle of rotation. The angle of rotation in 1 second. In simple language we can say like that. Angle of rotation in 1 second. A rotating body, in 1 second how much angle it rotated. A body is rotating like this. A body is rotating like this. In 1 second time. In 1 second time how much angle it is rotated. A body is rotating about an axis. In 1 second time how much angle it rotated. That angle is said to be omega. Just like speed. Speed is the distance in 1 second. So angular speed omega is the angle rotated in 1 second. Simple. Now you understood? Omega is clear? Please respond. Ashlyn, clear ആയോ? Ashlyn, omega മനസ്സിലായോ എന്താന്നുള്ളത്? Devasri, Raj, Said, you understood omega?
Yes, sir.
Okay. So this omega we studied already. You studied in circular motion a rotating body which is at a distance of r meter from the origin, rotating about origin. You have already studied a body is rotating like this with an angular speed omega. Again and again I am telling you, omega is the angle rotated in 1 second, and its linear speed is v. V is the linear speed. What is v actually? In 1 second, how much distance the body traveled. V is not about angle, v is the distance. The body is moving along this path. In 1 second time, how much distance the body traveled, that is v, distance. But omega is the angle rotated in 1 second. In the topic circular motion, we have studied this formula. I think you forgot everything. That is why I am repeating this. If I don't explain this, you cannot understand anything. So the relation between linear speed and angular speed we studied in the topic circular motion. The radius of the rope is r, omega is the angular speed, v is the linear speed. Means in 1 second how much distance traveled. So the relation connecting v and omega is v equal to r omega. Is that okay? You understood? Clear? All of you clear? Please respond. Devasri, Raj, Ashlin, Said, understood? Said, not. Please respond. Raj, you understood? Response is very, very important. Raj, you understood? Raj? No response.
Sir, can you say what is speed?
What is? V is the speed in 1 second. Distance covered in 1 second. In 1 second time, how much distance traveled by the body along this track, circular track. In 1 second time, how much distance traveled.
Okay, sir.
We studied in the lower classes. V is speed. In 1 second time, how much distance traveled in the track, circular track. So what I am saying is, if the entire body is rotating with omega angular speed, I think still you remember, I think so, angle rotated in 1 second. If the entire body is rotated with an angular speed omega, every body also rotating, understood? Every body, every point object, point mass will also be rotating with the same omega. That is a property of the system of particle. Understood? It is very simple concept. Clear? If the entire body is rotating with the angular speed, every point mass also rotating in the same way, also rotating with the same angular speed, but they have a different speed, a linear speed. They have different linear speed. Means in 1 second how much distance traveled. The linear speed will be different, but omega will be same. The angle covered in 1 second will be same. So let me start. So the angular momentum of the system of particle, I am talking about the angular momentum of system of particle is angular momentum of each masses to be added. Angular momentum of m1 to be m1 plus angular momentum of m2 plus angular momentum of m3, etc., etc. Why? The total strength of the rotation is equal to strength of the rotation of each individual point masses. The total strength of rotation is equal to the strength of rotation of each individual point masses. So strength of rotation of m1 plus strength of rotation of m2 plus m3, etc. Is that okay? All of it clear?
Yes, sir.
Raj, Ashlin, everyone is clear? Said, you understood? Said?
Yes, sir.
Okay. L1, tell me the formula. Please tell me. What is L1? L1 is, the derivation is there in textbook, but I think they have used some sigma letter. But I think it is better to write like this. If I explain with the sigma, you cannot understand. So L1, what is angular momentum of M1? Please tell me. Angular momentum of point mass M1 is mvr sin theta. Angular momentum of a point mass is mvr sin theta. So angular momentum of M1 will be mvr sin theta. M1, V1, R1. All of you please listen. Theta will be 90 degree. Theta will be 90 degree. Because the velocity, look at the direction of velocity. M1, the rotation is like this. I will show you. Wait, 1 minute, I will show you. The velocity is tangential to, like this, sorry. The diagram, drawing the diagram is very difficult. The velocity is like this, tangential to the rotation. This is the direction of the velocity. Understood? This is the tangential. This is the rotating. Circular way it is rotating like this. M1 is rotating like this. As the body is rotating, M1 is rotating like this. Here the direction of the velocity is tangential like this. But R1 is like this. The velocity and R 90 degree. The velocity is like this, tangential. The M1 is rotating like a circle. So tangential is drawn. V1 is like this, linear speed, linear velocity. And R is like this, R1. Angle between V1 and R1 is 90 degree, clearly. So sin 90 I don't want to write. Theta, mvr sin theta, in which theta will be 90 degree. Sin 91 I don't want to write it. Let me complete the derivation. After that you can ask me doubt. Okay, it is discussed in the textbook. They use only sigma. Okay, you can refer NCERT. They use sigma, that is the only change. But you can understand only if I write like this. L2 is the angular momentum of the second mass. Angular momentum, M2 is rotating like this. You agree with me? M2 is also rotating like this. M2 has a strength of rotation. mvr sin theta, M2, V2, R2. In the same way, theta will be 90 degree. Sin 90 I don't want to write. M3, V3, R3, etc., etc. Let me complete the derivation. After that you can ask me doubt. Okay, it will not take too much time, don't worry. M1 into V1. What is that V1? V1 is the linear speed of M1. This one, okay. V1 is the linear speed of V1. In 1 second, how much distance traveled by M1? V1 equal to R1 into omega. V1 is equal to, we have a formula, V equal to R omega. So V1 equal to R1 into omega. Omega is the angular speed. So V1 equal to R1 omega. Let me complete the derivation. After that I will clarify your all doubts. Okay, V1 is R omega. We have a formula. So V1 here R1 omega. M2 into V2. V2 is the linear speed of second body. V2 equal to R2 omega. V2 equal to R2 into omega. Everyone has same omega. V2 is R2 omega into R2. The same way, etc., etc. Okay. So let me write M1 R1 square omega. M1 R1 square omega. M2 R2 square omega. M3 R3 square omega, etc., etc. omega is common. In every term, omega is common. Omega is taken outside. Omega is common, so omega is taken outside. Omega is taken outside. Have you seen this expression anywhere? Anybody? Please tell me. M1 R1 square plus M2 R2 square plus M3 R3 square, etc. Have you seen this expression anywhere? Anybody? No? In the previous class we studied moment of inertia. You forgot? You forgot moment of inertia?
Yes.
See, please reply. Do you remember moment of inertia m1 r1 square plus m2 r2 square m3 r3 square? You forgot everything. Why are you forgetting everything? See, this is I explained. You forgot it. The moment of inertia m1 r1 square plus m2 r2 square m3 r3 square, etc. The unit also I have written in the previous class. This is previous class note. Understood? So what I am saying is, one minute. What I am saying is m1 r1 square plus m2 r2 square, etc. is nothing but moment of inertia I. So angular momentum is defined as I omega. Please memorize. Case 2 is the for system of particles. So there are two cases. For point masses mvr sin theta, angular momentum, and for the system of particle rotating at an angular speed omega, the strength of rotation is given by angular momentum L equal to I omega. I is the moment of inertia, omega is the angular speed. All of you please write down. And if you don't understand any step, you please ask. Raj, you can ask me doubt. Don't worry. You can ask me doubt. Ashlin, എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടെങ്കിൽ ചോദിക്കുക കേട്ടോ. സെയ്ത്, you please read all the steps. Please read all the steps. If you have any doubt in any step, you please ask.